Hello everyone, and here we are with Unit 1, Lesson 3, Learning Target. I can solve linear equations with one or more variables using inverse operations. And what this is, it's a whole lesson on basically solving equations. So the do now, right now, says Jack paid an electrician X dollars per hour for a 5-hour job plus $70 for parts. The total charge was $320. And what the question is asking you to do, the question is asking you to create an equation that's for part A, and then B, to solve that equation, and then C, what does the value of X represent? Not just a number, but what it represents in words to you. So let's just go ahead and do this, the first part together, and then we'll pause the video to let you just solve the equation. So the Jack paid an electrician, and the way I like to do this is to underline like important bits of information. So obviously it's X dollars. They paid an electrician X dollars per hour. So it's a 5-hour job, and it's $70 for parts. It's the plus that is right there. That's important. And the total charge was $320. So I'm going to say, all right, if he's paying the electrician X dollars per hour for 5 hours, that is 5 times X. This plus, pretty easy. Plus what? Plus 70. And always the total is equals, and then 320. And now what you have to do to put that equation together is to put that information that you have right above the words. And that's why I like leaving everything and just putting everything, underline it, the most important information, and then putting that stuff right above the words itself. And then you could take a look and you could actually see what that equation would be. So here we go. We're going to create that equation, and there it is. It's 5x plus 70 equals 320. Now what I want you to do is solve that. That's a two-step equation. Hopefully you can try it, solve it, press pause now. So just to get you through this, remember, inverse operations every step of the way. 5x plus 70 equals 320 is the equation. As soon as you see that plus 70, you subtract 70 on both sides. What you do on one side, you have to do on the other. So just remember, if you see an addition, opposite of addition, inverse operation, subtraction. So you minus 70 on both sides. And then now the only thing that is on that left-hand side, left is 5x, you bring it down. You see this equal sign, you bring it straight down. 320 minus 70 is 250. So now all you have to do is opposite. You have to solve for this x. You have to isolate the variable. So opposite of multiplication is division. So you're going to divide by whatever number is next to the x. And now you have 250 divided by 5, and because you have to do the same thing on each side, and you have x equals, and hopefully you did that. When you put this into the calculator, 250 divided by 5. So this is the calculator that we're going to be using, this TI-84 plus. So just a shortcut, and we'll get into like various shortcuts on this calculator. So this alpha button, if you press it, and if you press X, it brings you to a fraction from the numerator and the denominator all ready for you. It's alpha and X. So let me clear that again, alpha and X, and then that calculator is ready. So when you have 250, this is how we're going to do division. You put the 250 in as the numerator, and then you press the down button, which is right here, and you press 5 and you press enter, and that is 250 divided by 5, and that is 50. So just remember, knowing how to use the calculator is just a very important part of what we're focusing on. So what does the value of x represent in the equation? So we know that x equals 50, but that doesn't tell us what it represents. And it's basically what the electrician is paid per hour. So if you're going to put it down, the value of x represents what the is paid per hour, or is hourly rate, you could say. So very important, what that electrician is paid per hour. Okay, so don't worry, you'll never answer these questions as far as like on a Regents or on even on one of our tests. It's just to get things started. Please go ahead and do 1, 2, 3, and 4, and we'll come back and just check them. And remember, when you do a check, you just get your value of x and substitute it back into the equation and see if it works. Go ahead, press pause now, try all 4, get the answer, and then we'll come back and review. Press pause now. So I just finished the first 2, and here we are. You subtract 7 on both sides. Remember, if you see positive plus 7, you subtract 7. X equals 3. To check, you put the 3 that you have here, x equals 3, and you put it directly into the equation, the original equation. As x, you have 3. 3 plus 7 equals 10. 10 equals 10. Check mark. Same thing here. You add 3 on both sides because you have a minus 3 up there. Opposite of subtraction is addition. So you get x equals -1. And now I check -1 minus 3 equals -4. -4 equals -4. Just to take the calculator and show you how to put a negative in. It's much like the TI-34 that you used last year. You have a negative, which is down here, -1 minus 3. And that's how you would put that in. And you get a -4. Just wanted to show you that right away. All right. So just taking a look, hopefully you did finish number 3, and you again have to divide by 3 because the opposite of multiplication is division. X equals 5, and that is your answer. When you go to check this, it is 3 times 5, so you're going to put that x in as your answer. Whatever you got as your answer goes in as the x. So it's 3 times 5, and now 3 times 5 is 15. So the last line of your check should be 15 on the left side, because you got that right, and 15 on the right. Yes, those are equal. You put a check mark, you're done, you're out of here. All right, so number 4. People have a lot of trouble with this. Right? You can do this a lot of ways, but I'm just going to show you that this is division. This is what this is. It's division. So the opposite of division is what? It's multiplication. So I'm going to put a dot right here. And I'm going to multiply by 4. Because you always like multiply a fraction by its reciprocal. So and to get them to cancel out. So this is really like 1 over 4 times 4 over 1. Since there is no 1 showing here, but you know there's a 1 next to that x, it is really like 1 over 4x. But I'm just saying you multiply by 4, and if you have to multiply by 4 on the left side, multiply by 4 on the right side. And what happens, do you remember cross-canceling? Well, that's what happens when we multiply by the reciprocal. right? So you're taking whatever numbers down here, that's what you multiply by. And therefore, so you notice how they cross cancel, and the only thing left on this left hand side is an x. And this is not a plus, this is a times, it's a multiplication symbol, and that is 12. And for the check, you just do it the same way. You put the 12, your answer, into the x, substitute into the x, and you divide it by 4. 12 divided by 4 is 3. And you know that 3 equals 3. And that is a check mark. Congratulations, y'all. All right, so discuss what are the inverse operations. What are inverse operations, and how do they help us solve linear equations? Go ahead and try to answer that. Put what you think are what inverse operations are and how they help solve linear equations. Go ahead, put that down, press pause now. So hopefully you were able to answer that, and if not, we'll go over it right now. Inverse operations are two operations that are opposites of each other, and they undo each other. And when we're saying undo, that means if you have addition, you subtract that same amount, it equals 0, they cancel out. So they undo each other. Multiplication and division undo each other. So it helps solve an equation by eventually isolating the variable. So if you do all of the inverse operations, you will eventually isolate the variable and get what that variable is as a number. And that is it. Hopefully you got that and that helped you out. So just the properties, I know we did this in the first lesson, but the properties of equality, just want to go through them because they are mentioned and they are important. The addition property of equality, if you add the same number of both sides of the equation continues to be true, right? And it says if A equals C, then A plus B equals C plus B. And to me, that's like, all right, what I don't know what you're talking about. If A equals C and A plus B is C and C plus B is equal to each other. Okay, so I'm just going to give random numbers. I'm going to assign random numbers to each variable. So just say A equals 5. All right, I'm just going to put A equals 5. I made that up. I did not get that from anywhere, right? If A equals 5, look at it says if A equals C, so that means C equals 5 because they are equal to each other, right? So if A and C are equal to each other, that means if I put A in, right, and all right, B, let's see, B could be equal to 2. Again, just making it up. So 5 plus 2, A plus B, has to be equal to C, which is 5 plus 2. See how they're equal? Right? That's the addition property of equality. In other words, if you took the same number plus the same number and then switched another number that was equal to A, like C is, and then added that same number to it, it was definitely going to be equal to each other. And that's it. So to move on and use the same numbers, remember A equals 5. And C equals 5. Right? Right. B is going to continue to equal 2. So subtraction property of equality, if you subtract the same number from both sides of the equation continues to be true. Of course it does. So look, 5 equals 5. A is 5, so is C. So that means A, which is 5, minus 2, which is B, and I just made that number up, equals 5 minus 2, because C is 5 also. equal to each other. That is subtraction property of equality. Now moving down to multiplication property of equality and thinking about A equaling 5 and C equaling 5. The same thing happens. So you have 5 equals 5, right? Because A and C are equal to each other. And so here I did 5 equals 5, and then A times B, which is 5 times 2, B remaining 2, and A is 5, equals C, which is 5 times 2. All right, obviously 10 equals 10. Division property. If you divide both sides of the equation by the same non-zero number, can't be 0, can't divide by 0, the equation continues to be true. Again, if we put 5 equals 5, if I put A and C equal to each other, and B cannot be 0, which I already said B is 2, then A equals C once you divide. So if, like, say if B equals 2 again, and you divide 5 divided by 2, because A divided by B, then you take C, which is again 5, divided by B. 5 divided by 2 is 2.5. 5 divided by 2 is 2.5. That's the division property of equality. That's all that says. All right, go ahead and see if you can solve and check both of these equations. By the way, we're not going to check that much. This is probably the last time we're going to check. I just want you to know, if someone asks you to check something, that you're not sitting there saying you have no idea. Go ahead, do numbers 1 and 2 and see if you can check it. We'll come back with the answers in a little bit. Press pause and try right now. Pause. So here we go. You add 12 to both sides for number 1, and you cancel that 12 out. On the other side, you have 30. 3y equals 30 divided by 3, and y equals 10. You take this 10 and substitute it in for y in the original equation. Minus 12 equals 18. 30 minus 12 equals 18. 18 equals 18. That checks out. Over here, 2x plus 11 equals negative 19. Again, you use inverse operations. Subtract 11 on both sides. Just remember, negative 19 minus 11. Use your calculator if you get confused with that. Do not get that wrong. It's negative 30. 2x equals negative 30. Divide by 2 on both sides. You get x equals negative 15. You go through the check. Negative 19 equals negative 19. Go ahead and try to solve this on your own. Press pause now. So I'm going to try to do this, hopefully if you did do it, that's great. If you didn't, you were waiting to see what I was going to do. Obviously you have parentheses on that right hand side, so what you do is distributive property. The one property that we didn't really talk about right now is distributive property. So you have to get rid of those parentheses. Must get rid of those parentheses. It is 2 times c, which is 2c, and then 2 times, I know this says minus 5, but it's like a 2 times negative 5, and that's a negative 10. It's not like you're bringing the subtraction down, this minus sign down. If a teacher tells you that, don't do it. It is positive 2 times a negative 5, and that's a negative 10. Now when you have this type of equation, you have variables. You see this c and you see this c? You have to bring them together. So I always start with the smallest c, smallest number in front of c. So you have 2c, and I'm going to minus 2c from both sides. I'm not going to divide because I don't want to break up the 2c. Right? So I just want to take the smallest coefficient, and that's the number before the variable, and bring it over to the left side, because the 5c is over there hanging out on its own, and you want to bring them together. So when you do that, this cancels, and then you won't work in that negative, right? So that's a good thing. So 5c minus 2c, and that is 3c. And then you just bring everything else down. Don't try to do anything else. And it's equal sign, and it's a negative 10. Now what you have is a two-step equation. And you know from having a two-step equation that you minus 4 on both sides. So you're taking, again, another step. And then you're resetting. This negative 4 and positive 4 cancel out. And you have 3c equals negative 14. By the way, if you have the same sign, negative 10 and negative 14, you add them together, keep the negative. All right? Then you divide by 3. This 3 cancels, c comes down, and you're going to bring your calculator up, right? And remember I told you alpha x, beautiful, right? Negative 14 as the numerator, press down, and 3 as the denominator. Enter, and you get negative 14 divided by 3. I don't know, like, why did it give me the same thing back? So take a look. You see this math button? See how it says fraction? We don't want that. We want a decimal. Press enter. You bring it down to decimal. Press enter. It's going to take your answer and get a decimal out of it. I still don't see that somewhere here, but it's not c equals negative 3. It's not c equals negative 2. And it's not c equals negative 1/3. It's negative 4.666, and that's this. A is your answer. All right? So just be aware of how to use that calculator. That math button is very, very important. Here is a sample regions question, and sample regions questions are fun. All right? When solving an equation 4 times 3x squared plus 2 minus 9 equals 8x squared plus 7, Emily wrote 4 times 3x squared plus 2 equals 8x squared plus 16 as her first step. Which property justifies Emily's first step? Go ahead, write it down, take that first step, see what Emily did, and choose one of those choices. Press pause now. Taking a look at what Emily did here, obviously she went from here to here. So what's missing? The negative 9 is missing. So if the negative 9 is missing, guess where it went? It went over here. So she added 9 to both sides, and then she got this, which is 8x plus 16, and then the 9 is canceled out here. Which property is that? Hopefully you did choose. The addition property of equality. All right, so much fun. It looks really difficult. Please do not think that this is difficult at all. Actually, it's pretty easy. Remember, you have x's on both sides, right? You have to get them together. Try to get your smallest x over to the largest x. And in this case, just get the x's together. So bringing this 11 over 3x over to this 2 over 3x will not help you at all. But bringing this 2/3 x over to the 11 over 3, that will help. So that's what I'm going to do. So I'm going to just take this and bring it over. Anytime you want to pause and try this on your own, that would be better than just watching me do it. All right, so these cancel, and we have 12 equals, and then, oh my goodness, we have all these fractions, but who cares? 11 over 3 minus 2 over 3. That's 9 over 3. You have like denominators. You could subtract or add the numerators. 9 over 3, 9 divided by 3 is 3. So you just do 12 equals 3x. And that's a single step equation, 6th grade question that it boils down to. You see how easy that was? Don't worry about the fractions. You have a calculator, and for this one you didn't even need the calculator, so it's 4. Alright, x equals 4. You're finished. You're done. And move on. So just remember, you have the distributive property here. Alright, take that first one. We'll come back with the answer, and then we'll do that second one. Okay? So the first one, try it, press pause now. Okay, so hopefully you did give that a try, and hopefully you did get x equals -9. Let me just explain. The first thing I did was 2 times x, and 2 times x is 2x, so I put it down there. The second thing I did was 2 times 5, and then that's 10, equals -8. I just brought that down. Minus 10 on both sides. You subtract 10 on both sides, and then you cancel out, because again, this is inverse operations. Remember, subtract 10 on both sides, cancel the 10s because this equals 0. -8 minus 10 is -18. You bring the 2x down, you bring the equal sign down. Opposite of multiplication is division, so that means you're dividing by whatever is next to that x to isolate that variable. So you divide by 2 on both sides, you get x equals -9. This one again started out like distributive property, the same thing. And just remember, you see these x's, so let's just do distributive property right off the bat. The x's are on the same side. They're not on opposite sides, so opposite sides of the equal sign. So that means you're going to have to combine like terms. And so do distributive property, combine like terms, and then solve. Okay? Give it a try. Press pause now. Alright, so I did distributive property. It's 6 times x, 6x. 6 times -4 is -24. You bring down the plus 3x, you bring down the equal sign, you bring down the 3. So we have 6x minus 24 plus 3x equals 3. And this is what I'm talking about with not greatest common factor, combining like terms. So you have 6x and 3x as like terms on the same side of the equal sign. So that means that you are going to combine like terms. So 6x plus 3x is 9x. You bring down the minus 24, and you bring down the equal sign, you bring down the 3. And you have a subtraction, minus 24. You add 24 on both sides because that's inverse operations, and you cancel that out. So you have 9x equals 27 because 3 plus 24 is 27. You divide by 9 equals 2, and then x equals 3. Alright, and that's really basically it. So it says try to solve this equation on your own, but there's 2 of them. So it should say these equations on your own. Alrighty, so I'm going to do this one on the left-hand side of your screen. I'm going to do that one with you, and then you can take the one on the right-hand side of the screen. So obviously, you just take everybody freaks out when they see fractions. Don't freak out. Just do what you normally do. You're going to subtract the 5. You have to get the 5 over to the other side. So now you have 2 over 3x equals -4. Now what most kids coming from the 7th grade do is divide by 2/3. You can. I'm not saying you can't, but I'm going to show you a different way. All right, this right here is a fraction. If you multiply 2/3 by its reciprocal, which you're going to switch the numerator and the denominator, if you multiply it, all it does is cancel it out. And look what happens. I'm going to put a dot right here, and I'm going to put 3/2, which is the reciprocal of 2/3. And I'm going to put 3/2 here. And remember, this -4 really has a 1 underneath. You really don't need to put that 1. It's just, it is there. All right, so you have 3 cross-canceling with 3, and you have 2 cross-canceling with 2. Look at that. X is alone. Equals. -4 times 3 is -12. And 2 times 1, which is 2. X equals -6. Because -12 divided by 2 is -6. Your answer is finished. You're done. I am just telling you the way I just did it with the reciprocal. Your high school class, your algebra class, anytime that you go to high school, that's the way they're going to do it. All right, so dividing is not wrong, but reciprocal is the way to go to get rid of a fraction. 1/2 times 2/1 cancels out. All right, so it's the same thing over and over again. Try the right hand side, do it whatever way you want, but try to use the reciprocal the way I showed you on the left hand side. Press pause and try the problem now. So just take a look. I subtracted 8 on both sides. We know how to do that. Then you bring down the 3/4x equals -6, because 2 minus 8 is -6. I multiplied by the reciprocal instead of dividing. Look, 4 cancels with 4. 3 cancels with 3. Look at that. X. It's one step. Like, it's just really good. -6 times 4 is -24. And then divided by 3. -24 divided by 3, you can even use your calculator, is -8. And that's it. All right, so to be able to solve, combining like terms, to be able to solve an equation, we must group like terms together. All right, like terms are terms that contain the same variable or group of variables raised to the same exponent. So if you have like something like 2x squared plus 6x squared, that is 8x squared, regardless of the numerical coefficient, right? So if you have the same variable and exponent, you could say that they're like terms. So in your groups, we're not going to say in your groups, but just say, you know, I know you're alone watching this video, so you can't do it in your groups, but discuss the steps you would take before solving the variable. You really don't have to do that. Solve the equation, right? So we're talking about combining these like terms, and I'm just going to underline them because I know a lot of people like to either box them out or underline. I like to box them out better than underlining, because underlining looks like a division symbol, a fraction. So if you box them out, those two numbers are like terms, you're going to combine them first. Go ahead, do the green side and the red side. Press pause now. So I did combine like terms. I have 9x plus 5 equals 24. Subtracted 5 on both sides. Yet 9x equals 19, which doesn't look like anything that I could use. So I'm going to move this over here, and I'm just going to show you. First off, I just want it a little bit bigger. Right? I'm going to clear out everything. And then I'm going to go alpha x, and then I'm going to have 19 divided by 9. Now, enter. It's going to give me the same thing. I could press math and then go over the, I can press math and go down to 2 and then press enter. And I have 2.1, with a line on top, which means that the fraction goes on forever in that way. By the way, if you use this and you put this the old-fashioned way, you have 19 divided by 9, and you press enter, you'll get 2.11111. So whatever way you want to do it, I just wanted to show you that little shortcut on the calculator. Right? Hopefully you did the right-hand side already, but if you didn't, press pause, give it a try now. So what we did here, I'm going to box out the like terms. Since these x's are on the same side of the equal sign, I have like terms. And like terms are things that, first off, you know that this equation, looking at the equation, it has 3 terms on that left side. You know it has to go down to 2. All right, so you're taking the 3x, negative 3x, and the positive 6x. Negative 3 plus 6 is 3. So it's 3x minus 2 equals negative 20. You add 2 on both sides, inverse operations. You see a subtraction, you add. And then you have negative 20 plus 2. And all the time that you're using your calculator, you're using it for something like this. Negative 20 plus 2. Negative 18. Right? You're not getting that wrong. So we have negative 18 divided by 3, and that's negative 6. And that is it. All right, there's a challenge on the bottom here. It is not that difficult. Remember, we'll take this together. But remember, we're talking about like terms. And like terms, this is a 4x squared plus 6x squared, like terms, equals 90. So think about what you would do to combine these like terms. These are like terms. What would you do? When you combine them, what do you get? Well, 6 plus 4, that's 10. X squared equals 90. What would you do right now if you had just a 10x equals 90? Well, if you said you would divide by 10, you're correct. And in this case, it's the same thing. You're dividing by 10. So we're canceling it. And this is the x squared coming down instead of x. And 90 divided by 10 is 9. So right here, a lot of people would be stuck. And if you're stuck, you're not alone. There are other people that have no idea what to do. So addition and subtraction are inverse operations of each other. Multiplication and division are inverse operations of each other. But there's also another set of inverse operations. And that set of inverse operations has something to do with x squared. Does anybody know what is the inverse operation to x squared? Of x squared. If you said square root, you're correct. Square root and x squared undo each other, like addition, subtraction, like multiplication and division. So what you do on both sides to undo both sides, if you see something squared, you square root it. And what happens right here is that this squared and this square root, the square root of x squared equals x. And the square root of 9 is 3. And that's it. That's your answer. So just remember, there's 3 sets of inverse operations. Just remember that x squared and square root are inverses of each other. And that is basically it. So just wanted to show you this slide for a second. It says sometimes variables appear on both sides of the equation, and you must get those variables to the same side of the equation. The variables cannot stay on separate sides. So you're talking about 10x. It says try bringing the smaller over to the larger. You're talking about 10x plus 20 equals 4x minus 40. So unlike the like terms that we dealt with in the last 2 problems, these are like terms, but you need them over to the same side. So what I have here is a small dog, and this 4x is a smaller coefficient, and this big dog is over here barking at the small dog to come over through the fire. So we're going to get this small doggy over to the big doggy, and everything will be extremely good because they'll be together. So how would you do that? And what you do is that you're taking the opposite of a positive 4x and you subtract 4x. And you're passing that equal sign. It's like you carrying this whole 4x over to the 10x. And let me just put a big line there. And this cancels. And you see what happens, 10x minus 4x, that's 6x now. And then now you have the plus 20. You bring down everything right below it or close to it, equals negative 40. And then you have a two-step equation, and you just go ahead and you solve. And as I do it, go ahead, you do it. This cancels. I'm going to move this down a little bit so you can see. And now you have just 6x equals negative 60. And one step that you have to take to solve, to isolate the variable, you divide by 6 on both sides. X equals negative 10. All right. Try to bring the smaller over to the larger. It is not wrong to minus 10x on both sides, but if you do minus 10x on both sides, you will have to divide by a negative. And when you get into solving inequalities, that means that you would have to change the reverse the inequality symbol, and it sometimes gets a little tricky. All right, so try to avoid it if you can. Go ahead, see if you can do this bottom one we did already, so you can get that out of there. You don't have to do the fast finisher. So I am just going to go ahead and delete that fast finisher and delete this extra spicy stuff. Go ahead and see if you could do the green side and the blue side. Do not worry about checking it. Do not worry about checking it. We're not going to check. Just solve each one and we'll come back with the answers. Press pause now. Okay, here is what I did. I subtracted the 2x on both sides. I needed to get the smaller x over to the larger x. I wanted to get the smaller x. I didn't need to, but I wanted to. So I have 4x minus 2x is 2x, and you bring down the negative 3, bring down the equal sign, bring down the 21, add 3 on both sides, cancel that out. 2x equals 24, divide by 2, x equals 12. On this side, this smaller coefficient is negative 5y, so I added 5y on both sides. You have 7y plus 5y, and that equals 12y. You bring down the minus 3, bring down the equal sign, you bring down the 45. If you subtracted 7y from both sides, you would end up with negative 12y on the right side. So that means don't worry about it. If you could avoid working in the negative, you will, just do it. Bringing the smaller over to the larger will avoid that. All right, so you have 12y minus 3 equals 45. You add 3 on both sides, you get 12y equals 48. You divide by 12, y equals 4. Hopefully you got those correct. If you have any questions, just make sure that you get in touch with us. All right, consider the equation below. You have 5 times x plus 2 plus 2x equals 6x minus 10. Which property can be used to simplify the expression? Obviously, the first thing that you do, and we talked about this already, the first thing that you do all the time to get rid of the parentheses is distributive property, and just write down what you would get for distributive property right next to it. You have 5x, 5 times 2 is 10. Alright, so that's just one step there. There are 2 steps in distributive property, but you have to get rid of those parentheses before you start the equation. So go ahead, see if you could rewrite this equation down. We're going to clone it. I'm going to clone it. And I'm going to bring it down here. And we're going to just go through the steps, right? There's a fast finisher on the bottom. So I guess give that a try also, but do this one first. And make sure that you have all the steps down. So I already did the steps with the distributive property step. 5x plus 10. After you do that distributive property, I don't want you to take another step. Just go ahead and rewrite everything. Don't take another step. Just to make sure. A lot of people would say, all right, let me see if I can bring this 5x over here, this 2x over here. That's kind of like mishmashy, right? You don't want to do things that way. You see this left-hand side, it has 3 terms. You need it to get it down to 2 terms. So that means if there's 3 terms on one side, that means there's like terms somewhere that you could combine. All right, do you see the like terms? Yes, hopefully you do see the like terms. You have 5x here and you have 2x here. I don't want to do the whole problem with you, but go ahead and see if you could combine those like terms and then get the x's together. There's a lot of steps to this problem. Go ahead, see if you can do it, and then we'll come back and we'll go over it. Press pause now. So I didn't finish the problem, but I just wanted to make sure that you don't do anything that's like a misstep, that people fall in, like a trap that people usually fall into. You have 5x plus 2x is 7x. You bring down the plus 10, you bring down the equal sign, you bring down the 6x minus 10. Now you bring the smaller x over to the larger x, so it's minus 6x on both sides. And look, 7x minus 6x is 1x. You just put x down, don't put the 1 in front of it. It's known that that's a 1x if you put x. You bring down the plus 10, you bring down the equal sign, you bring down the negative 10. Now you go like this, you subtract 10 on both sides, but I don't want you to think that this right side is equal to 0. It's not. This is equal to 0, right? So x, it's not equal to 0. That x is not equal to 0. X is equal to negative 20. Even check it out on your calculator, negative 10 minus 10. That is negative 20. So if you want to try that fast finisher on your own, go ahead. You can press pause now. But I'm just going to tell you, work through it with you. Because, I mean, this is a Regents question. Like, this is what a Regents question will look like as far as like with these fractions and everything. People are afraid of fractions. You have a calculator by you at all times, so it is absolutely no problem to use that calculator. And in this case with fractions, I don't even think it's necessary to use the calculator, but if you want to use it, okay. But 3/5 x, 3/5 times x is 3/5 x. Just look, they're both positives, right? This is a positive 3/5, this is a positive 4/3. Just multiply numerator times numerator. You could do 4 times 3. 3 times 4 is 12, right? 5 times 3 is 15. Keep it that way, right? It equals 1.04, right? Okay, grab your calculator. All right, so I'm just going to go 12 divided by 15 and see if it comes out to something I could use. Look at that, 0.8. 12 divided by 15, that's this. So when I'm rewriting this, I'm not going to rewrite 3/5 as a decimal because that's a repeating decimal. But just to remind myself, that's 0.8. So that means I have 0.8 equals 1.04. And then treat it like any other question. You subtract the 0.8, right? Subtract 0.8. Grab your calculator again. And you have your calculator right near you. I'm going to clear it out because I don't like the way that screen looks. And it's 1.04. Put it in just like I'm doing. Minus 0.8. 0.24. Let me just make sure. 0.24. Equal sign comes down, and so does the 3/5 x. Now, do you remember how I told you to solve this? You could do it any way you want, right? I'm going to always go with the reciprocal. And if you're using the reciprocal, this is the way you do it. This cancels, this cancels, this cancels, this cancels. X comes down, equals, and I'm going to grab my calculator again. And I am going to put 0.24 times, and look at this, alpha x. How great is that? Because now you have 5/3, right? Enter. 0.4, 2. 2's your answer. You have 0.4. It's great. Love the calculator. Love it. It's not just that I'm a teacher and I love it. It's just that it gives you the answers, and anything that gives you the answers I kind of love. All right, because I did everything by hand in my day, and it was miserable. All right, go ahead, see if you could do this mid-lesson assessment on your own. Get the answer, circle it, we'll come back with the answers. Next. Press pause now. Okay, so there it is. You do distributive property, 3 times x, 3x, 3 times -2 is -6, equals -18. You add 6 on both sides, divide by 3, you get x equals -4. That is your answer, and that's it. Go ahead, see if you can do these. Remember, if there's not enough room, please go ahead and, just put it on a piece of paper or something like that just to get yourself through. Okay, and that's about it. You can press pause. We'll come back with the answers in a little bit. Press pause now. Okay, so number 1 is a equals 12. Just take a look at my work. I added 7 on both sides. I have 3/2a equals 18, and I multiplied by the reciprocal of 3/2, which is 2/3. On both sides, you got a equals 36/3, a equals 12. We have on this side, it looks like a tremendous question. It looks like a long question. We have 7x plus 5x. We have to do distributive property first. You have 5 times x is 5x, 5 times -1 is -5. Combine like terms, which is 12x minus 5 equals -6 plus 10x. Now I got the 10x over to the 12x by subtracting using inverse operations. You have 12x minus 10x is 2x. You bring down the -5. You bring down the equal sign. You bring down the -6. You add 5 on both sides. and you get 2x equals -1. You divide by 2 on both sides, you get x equals -1/2, which is your answer for number 2. Go ahead, try number 3 and number 4 the same way. Do distributive property first, combine like terms, solve. Press pause and try these 2 problems now. Wow, that was a lot of work. So we did distributive property over here. 3 times 5x is 15x. 3 times -4 is -12. And you bring down that -9x, bring down the 5x plus 5. Bring down that equal sign, and you have combined like terms. You have 15x minus 9x on the same side, so that's 6x. Right. So you have 5x plus 5 equals 6x minus 12. Subtract 5x on both sides. You get x on this side minus 12 equals 5. Plus 12 on both sides, you have x equals 17. Hopefully they did get that. Distributive property again right here. And then 3 times 2b, and that's 6b. And 3 times -1 is -3. Bring down the -7, equal sign, the 3b minus 13. You combine the -3 and the -7 because they're on the same side. They are like terms, even though they don't have a variable. -3 minus 7 is -10. And you have 3b minus 13. You subtract the 3b on both sides, smaller over to the larger. 6b minus 3b is 3b minus 10 equals -13. You add 10 on both sides. You have 3b equals -3. Divide by 3 on both sides. You get b equals -1. Alrighty. Alright, number 5. It looks like this, and we are going to do this one together and then skip the challenge. So we have looking at number 5. So we take a look at this, and what is this? This is a proportion, right? You have an equal sign in the middle. So just make it easy for yourself and cross multiply, right? So c times 54 is 54c. Let me start up here. Always give yourself a room, right? 54c. And the way you put that's that, right? So now you have to multiply this way. So it's 24 times c plus 20. And you put it in parentheses because it's the 24 times the whole c plus 20. So bring this down. 54, and that's a bad 5. 54c times 20, do distributive property, 24c times 20, which is 480. I have to look down for a second. Do you see how there's c's on opposite sides? What do you think you'd do to get this c over to that c? Well, if you said subtract, you're correct. 24c minus 24c. You are correct. You could take your calculator out and go ahead, figure out what 54c minus 24c is, and it's pretty easy because it comes out to 30c. Equals 480. So you divide by 30 on both sides. Grab your calculator. This cancels. C equals, grab that calculator, 480 divided by 30. 16. So 16 is your answer, and that is it. So don't ever look, you're taking a look at two fractions now on side by side with an equal sign in the middle. Cross multiply like you can with any proportion, and that's about it. Skip the challenge. All right. So this investigation, this is a productive struggle, and a lot of it is rather difficult to wrap your head around. They have the same perimeter. So just remember, wait a minute, they have the same perimeter, so this is a square, so that means that every single side of this square is x plus 3. So go ahead and put x plus 3 and an x plus 3 and then an x plus 3 down. This is an equilateral triangle. What does an equilateral triangle mean? All equal sides. So you have 3x minus 1 on that side, and you also have 3x minus 1 on this side. Right? Is there an equation you could set up? And remember, first off, perimeter. How do you figure out perimeter of any square, any figure? Perimeter. I always liked perimeter because it was the easiest thing to figure out. Yes, if you're saying add up all the sides, yes, you're correct. You're adding up all these sides. So what kind of equation would you have to set up just for this square? How many sides are there? If you said 4, you're correct. So we're going to have 4 times that amount. That's the square perimeter. It's said that the perimeters are equal. What are you going to put in the middle? Yes, you're going to put an equal sign in the middle. So now you have an equilateral triangle. So you have how many sides? 3. So that's the equation. Please press pause and solve it. All right, do B and solve it, and then find the perimeter of each figure. Go ahead, solve it, and then find the perimeter. Press pause now. So take a look. Hopefully you did solve that, and x equals 3, and you think your perimeter is done? No, it's not done. All right, so we have to find the perimeter. We're not going to do that fast finisher. Just make sure that you understand that this is not x equals 3 is not the perimeter. So we're going to take 3 and we're going to put it in here. 3 plus 3. So this side is 6. And since the sides of a square are all 6, the perimeter of the square is 24. This perimeter should be 24 because they said that the perimeters were equal. But let's try it out. 3 times 3, because x is 3, we're substituting in. So 9 minus 1 is 8. 8 and 8. And yes, it works out. So the perimeter of both are 24. And that's basically how you do it. Skip that fast finisher if it's on your page at all. All right, go ahead, do these 2 problems. You have a solve on the left side and a challenge on the right. And that's about it. And actually, you could skip that challenge. Just do the A side. Press pause now. Okay, so we subtracted 1/4 x from both sides, and you had 2/4 x minus 12, and then you added 12 on both sides. I got 7 here. Negative 5 plus 12 is 7, and I changed that 2/4 to a half. It's 0.5, and it divided by 0.5, and at x equals 14. Skip that challenge. All right, it says create an equation to solve the dimensions of the rectangle. Pretty much the same thing here. Go ahead, press pause, just kind of figure it out. The opposite sides of the rectangle are equal. Create that equation using all of the sides, adding them up, and then making them equal to 36. Solve that equation, and then figure out the length and the width of each. Go ahead, you can press pause and try the problem now.
Okay, so we have 2x plus 3, two sides of that, so I put 2 times 2x plus 3, plus 2x because there's x here and x here, I added the 2 x's up, equals 36 because it says that the perimeter is equal to 36. When I did distributive property, I had 2 times 2x, which is 4x, and 2 times 3, which is 6, plus 2x equals 36. I combine like terms, the 4x and the 2x is 6x plus 6 equals 36. You subtract 6 on both sides, you get x equals 5. So that's the width, because this width and this width is 5x, right? X equals 5. But I have to substitute here. 2 times 5 plus 3. 2 times 5 for the length is 10 plus 3 is 13. So the length equals 13. And this problem is finished. All right. All right, so here we are with the exit slip. Please take a look at the question. It says which equation has the same solution as this one up here. Go ahead, give it a try, press pause, and pick your answer now. So this is a Regents question too, and I just want you to know, like, if you solve each one of these, you're going to be here for a long time. All right, so what I want you to do is take a step, like just do whatever you need to do. At least do distributive property, because none of these choices has distributive property in it. So we got half times 6. Anything half times a number is half the number. Or you could use your calculator, just put 0.5 times 6 and you get 3. Half times x is a half x, and then you bring down the plus 3x and you have a half x minus 8. This side is obviously right here. I'm just looking at the choices after taking one step. Half x minus 8 and 3 plus 2x on that side. So we have 3 plus 2x on this side. So 3 minus 2 half x, right? So but this is 3 plus 2x. There's no way, when you combine like terms, which is the next step, when you combine in these like terms, there's no way that this negative a half x is 2.5x. So just taking the next step, you would say that this is 2.5x, because 3x minus a half x is 2.5x. All right, and then we have equals, let me just get situated here, equals a half x minus 8. So you know what? This is out. There's no way it's 2x, it's 2.5x. It's out. Go on. Let's look at B. You have 6 minus x. All right. I don't even know how to get that. That's gone. 3 plus 5 over 2. Let me just take a look at what 5 divided by 2. 5 over 2. That's 2.5. Oh, wait a minute. This is 2.5x. That's this. Equals a half x minus 8. The answer is obviously C. It's the same equation. Look, I didn't even figure out what the answer, the same solution. I didn't figure out the solution. It didn't take me long. I took 2 steps. Right? So I have 6 minus x plus 3x. That's 2x. If you combine them, x minus 8, it's a half x minus 8. This is gone. C is your answer. That's how to do a Regents question. Right? That's how you're going to do it. And that's basically it. The fast finisher, just take 2 seconds, press pause, see if you could do that problem. Alrighty, here we go. So we have 3 times x is 3x, 3 times negative 4 is negative 12, equals 2 times x, which is 2x, 2 times negative 6 is negative 12. Subtract 2x on both sides, you get x minus 12 equals negative 12. Add 12 on both sides, you get x equals 0. And that's the fast finish. I hope you got that. All right, so this is basically a step-by-step example. All right, slide. This is to review at home. All right, if you have any trouble, this is the step-by-step view. We've done a lot of problems like this. On the left side, you'll see all directions and the actual words of what you have to do that is on the right hand side. So you could just take a look at it. The check is there for you. So if you need to know how to do a check, it's there. And that's basically it. This is the summary slide, so please write down 3 strategies that you need in order to solve linear equations. All right, and that's the end of the lesson. See you next time.